The main astronomical topic of this year is the object 3I Atlas. It, and this is an extremely rare case, came to us from another planetary system. In fact, some scientists are even suggesting this object might be of artificial origin. However, we have already reported on this 3I Atlas. But new data is coming in. Astronomers all over the world are now actively studying this mysterious object. What is on its surface, how it moves, what it really is, and how we can detect such new interstellar visitors. Today we're going to talk about it. This is the Unearthly Podcast. I'm Astronomer Vladimir Surdin. If you're interested in this topic, please give this video a like, and we're starting. The most current astronomical event worth discussing today, day in, day out for the next 6 months, is yet another visit of an interstellar object to the solar system. Another one, because this is already the third. Since 2017, this is the third time we have received visitors from who knows where, from the depths of the galaxy. But the main thing is that we have spotted them, found them in the sky, and begun to study them. The first was Oumuamua in 2017. What it was is unclear, whether it was an asteroid, a dried-up comet, or a spaceship. The second one was Comet Borisov. That was in 2019. And finally, this year, the third interstellar object was discovered. It is called 3I, meaning the third interstellar, and its name is Atlas. Atlas in all caps, because it's an acronym. Atlas is a system of robotic optical telescopes that, with almost no human intervention, scan the sky and find everything that interests astronomers. In this case, it was an asteroid, though actually it was initially identified as an asteroid, but it later turned out to be a comet flying toward us from the depths of the galaxy. However, whether it is indeed a comet remains to be seen, although it looks like one outwardly. It was discovered on July the 1st, but it had actually been spotted earlier. They just hadn't yet realized what it was. You know, this happens quite often in astronomy. We're used to it. The discoverer who made the discovery, who first pointed out that there was something interesting in the sky, is credited as the one who first identified the unusual properties of this object, sparking widespread interest in its nature. But before that, astronomers had also been observing the sky, photographing it, and studying it. You know, in astronomy, this happens quite often. We're used to it. Newly discovered objects are usually found on some old photographs. It's much easier to find something when you know where and what to look for. That's exactly what happened this time. Although it was definitively stated on July the 1st that an interstellar object had been discovered, astronomers immediately went to their archives, which are digital today, and began checking the previously imaged areas. Where had it been before? We don't just calculate the future trajectory of a space object, where it can be seen in a few years, days, or months. We always calculate where it was in the recent past, where it came from, and whether we might have seen it there in old photographs. This way, we extend the known segment of its trajectory, which then allows us to calculate its orbit more accurately. The same thing happened this time. Astronomers working with the TESS Space Observatory, I almost said space telescope, but then remembered that the TESS satellite actually carries 4 optical telescopes, 4 lenses, each with a wide field of view. This spacecraft was specifically designed to search for planets of other stars, and it has been very successful in finding them. But the vast amount of data, which is transmitted to Earth every few minutes and stored in computers, allows researchers to check what was happening several months ago in the area of the sky where this interstellar comet is expected to be found. And they found it. They discovered it in images taken on May 7th. May, June, July, meaning they extended the observable trajectory by 2 months, which then allowed them to calculate the object's further flight path more accurately. So, we already have a large segment of its trajectory. Let's take a look at how this object is moving. When 3I Atlas was first spotted, it was still beyond the orbit of Jupiter, but it was rapidly approaching the center of the solar system at a speed of 60 kilometers per second, a tremendous velocity that precisely revealed its interstellar nature. Calculations show that on October the 3rd, 2025, it will pass near Mars. Well, what does near mean? At a distance approximately 5 times smaller than that between Earth and the Sun, 0.99 astronomical units. It might seem like a large distance, millions of kilometers, but what matters is that several spacecraft are operating near Mars, and they will be much closer to this object than our ground-based telescopes. We will try to observe it through the lenses of those very spacecraft. The encounter with Mars will occur on October 3rd. Of course, Mars's gravity will slightly alter the orbit of this new comet, causing it to deflect a little and continue its approach toward the center of the solar system. On November 3rd, the comet will pass near Venus. Well, what does near mean? About 100 million kilometers. Still, it is a certain approach. On December 19th, there will be an approach with Earth. However, it is a very distant approach, meaning the minimum distance from our planet will be almost twice the current distance between Earth and the Sun. Why? Well, because the comet will be positioned roughly the same distance behind the Sun. At that moment, the Earth will be on one side of the Sun, and the comet will be passing by on the other. The distance itself isn't prohibitively large. We could study this object in great detail with our telescopes. However, the Sun will be directly in front of it, with the comet flying behind. This makes it very inconvenient, practically impossible to study from Earth. That's true. We noted that there are several space observatories flying near Earth that are specifically designed to study the Sun. These include the Solar Dynamics Observatory and the even older SOHO Observatory, Solar and Heliospheric Observatory. They are capable of observing the Sun by blocking its disk with a special occulting disk in order to study the areas of the sky near the Sun. The next close approach is already on March the 16th, with Jupiter. It's going to be a very tight one. Considering Jupiter's enormous mass, the comet will pass so close that Jupiter will significantly change its orbit. And this is where the romantic ideas come into play, I would say. What is the romance all about? Of the 3 interstellar objects, only one doesn't raise any questions, Comet Borisov. By all accounts, it's a comet. No peculiarities were noticed in its motion, nor was there anything special about the gas evaporation from its surface. However, the first one, Oumuamua, and the current one, 3I Atlas, do raise questions. In many respects, they don't quite align with our understanding of natural bodies, meaning icy comets. Both Oumuamua and the current one are moving in a very strange way. Excess acceleration was detected in Oumuamua's movement, meaning it was moving away from the Sun, not only under the influence of the Sun's gravity, but also due to some unknown forces. Let's put it aside for now. The current comet arrived in the solar system in a very strange way. Its trajectory lies almost perfectly within the plane of all our planet's orbits. It gives the impression that it was meant to pass by most of the planets and make close approaches to them. But if this truly was a mission, it was a very correct one. If this is a spacecraft designed to study the planets of the solar system, this is exactly how it should have moved. Whether this was a preliminary calculation by fellow intelligent beings or a random coincidence, we don't know yet. But the truth is, its orbit seems highly improbable. It flies directly within the orbital plane of the planets and passes more or less close to nearly every one of them, Mars, Venus, and Jupiter. Yet it did not choose to fly near Earth. It's as if it hid behind the Sun when it passed, or more precisely, will pass, at its closest distance to Earth. I'm referring to October and November of this year. It gives the impression of a premeditated plan to hide from observers while still investigating the planetary system. Well, of course, all of this could be a coincidence, or it might not. These strange thoughts are suggested to us by, well, the now well-known Avi Loeb, an American astrophysicist who has been closely studying interstellar planets for years, with a feeling that they might be alien probes. And why not, after all? Even if it's not a probe, it's a gift from nature to our terrestrial astronomers. A sample of extrasolar substance. I mean matter that originated outside our solar system. There was a time when we were thrilled by meteorites falling to Earth and would say, "This is a gift from the heavens. We don't need to fly to the planets. They are throwing pieces of themselves right into the hands of scientists." And that's true. Meteorites are very valuable material. Now we say we don't need to fly to other stars, and we don't yet know how, because samples of matter from other planetary systems are coming to us. We've observed this 3 times already, and each time we have no way to study this matter directly. By directly, I mean flying to it, taking samples, photographing it up close, obtaining spectra of the substance, seeing what these objects look like. Why? Because they fly through the solar system at tremendous speeds and quickly exit it. Spacecraft development is a very slow process. It takes years and years to prepare a probe for a specific mission. But here, if an object flew away yesterday, it will have left the solar system by tomorrow. It entered with an incredible speed of over 60 kilometers per second, and after flying past the sun, it will reach a truly insane velocity 78 kilometers per second, I believe. We have never seen objects like this within our solar system before, but the reason is clear. Our solar system is flying towards them. To be more precise, it is flying towards the solar system's direction of motion. This results in very high combined cosmic velocities. But we still have telescopes. We are using them. And what have we found out about this object so far? It does resemble a comet it's outgassing, because the sun is heating it. And here, the surprises begin again. Usually, comets start to outgas when they cross Jupiter's orbit and approach the orbit of Mars. Why? Well, because the solar radiation heats them up sufficiently by that point, and the ice begins to vaporize. This one started outgassing at a great distance. It would seem that the sun still lacks the power to heat it up there, yet it is already outgassing quite rapidly. Based on the detection of hydroxyl molecules, it was calculated how much water the surface of this object loses every second. Why hydroxyl? Because a water molecule is not very stable, and when it leaves the comet's surface, solar ultraviolet radiation breaks it down into hydrogen and OH hydroxyl. So, by the amount of hydroxyl, it's easy to determine how much water this object is losing. It turns out to be 40 kilograms every second. That might not seem like much 4 buckets of water per second, but it's a significant amount for the cold region of the solar system, where we are observing this process. Well, besides that, there's another peculiarity. The Space Telescope Spherex, a relatively new infrared telescope, has detected the sublimation of what we call dry ice, solid CO2, carbon dioxide. Generally speaking, it sublimates more easily than water ice, but there's usually much less of it in the composition of comets. In this case, it turned out to be very abundant, surrounding the nucleus of this object with such a dense, temporary atmosphere. Astronomers call it a coma. This is where the name comet comes from. Coma. Well, in Greek, it means a head of hair. In the past, comets were depicted as a flowing head of hair trailing behind a maiden's head. That's how they are often imagined. Alternative version for the last sentence, slightly more literal. That's how people often visualize them. The unexpected thing is that space exploration might still have its say in studying this object. Although, of course, we won't have time to prepare a special probe. In 6 months, it will leave the central region of the solar system, and we won't be able to catch up with this fast-moving object. But we do have several spacecraft currently operating in space, heading towards planets and asteroids. Why not use them? It turns out that at least 2 such spacecraft are ready to join the effort. Firstly, there is Psyche. This space probe, launched by NASA engineers, is currently heading towards an asteroid of the same name, Psyche. This is a large asteroid that most likely consists almost entirely of pure metals. It is very interesting to understand its exact composition, what metals it is made of, which is precisely why the Psyche mission is underway. It has good optical equipment on board and will pass not too far from 3i Atlas. The second spacecraft is the one that was launched to study Jupiter's moon Europa. You may recall it's covered in ice with an ocean of liquid water beneath, which could potentially host life. Currently, 2 space probes are on their way there, an American one and a European one. Well, the trajectory of the European JUICE spacecraft will pass fairly close to the trajectory of this mysterious comet, and its onboard instruments will also be able to study it better than we can from Earth. Thus, at least several space observatories, both those monitoring the Sun and those currently heading towards the asteroid and the moon of Jupiter, will be involved in the research of this comet. But is it really a comet? Let's return to the hypothesis that this could be an artificial object. After all, we've been saying for years that civilizations across the galaxy must exchange information and visit each other. Each time, one of the assumptions inevitably is, fellow intelligent beings are coming our way. And now, a study has been published by young American astronomers who have compiled, at the very least, the facts one must consider to view any visitor to our solar system as a potential artificial object. What key properties should it demonstrate for us to say, yes, this is not a natural object, right? It is artificial. Well, first, its shape. And Oumuamua tells us about this. Remember? It has a strange cigar-shaped, or I'd even say pencil-like form. It's about 230 meters long, with a cross-section of around 35 meters. So, well, the ratio of its dimensions is roughly 1:8. Among the million asteroids we have discovered in the solar system, there is not a single one with such a cigar-shaped, or let's say, rocket-like form. Yet Oumuamua, the first to arrive from interstellar space, turned out to be exactly like that. Interesting. This should raise suspicions, and it did. Second, its motion. Let's return again to Oumuamua. After passing relatively close to the Sun, it was as if it activated jet engines. This might not be engines, but rather sublimation from the surface of a comet-like body. Actually, comets are known for this. As they approach the Sun, they heat up on one side, the side facing the Sun, and from that side, they begin to eject gas from their surface. Gas ejection is equivalent to the operation of a jet engine. The comet slightly alters its trajectory because of this, which is something we're accustomed to. And each time, we can see this ejected gas that is the comet's tail. Yet Oumuamua demonstrated nothing of the sort. It was as if engines were activated, but we observed no gas emissions. This, too, should raise concerns. Third is its appearance, or as astronomers say, its spectral composition. Roughly speaking, the color of an object's surface reveals its nature. Rock differs from ice, and a spaceship made of aluminum or stainless steel, like Elon Musk's, would shine in a way entirely unlike a natural object. Thus, the spectral composition of the light reflected from an object's surface can be a cause for suspicion and hint that it might be artificial. Or, for example, why limit ourselves to reflected light? If it is a rocket, internal systems are operating. Any spacecraft is heated from within, and also emits its own thermal radiation. Thermal, infrared radiation. An excess of infrared emission is also evidence pointing to the artificial nature of this object. And finally, Narrow-band radiation. What does that mean? When we tune a radio receiver to a specific station, we have to select a narrow band of frequencies, or a narrow wavelength range. To the left and right of it, there's no signal, but at a specific frequency or wavelength, there's a radio transmission. If we detect such a transmission or narrow-band emission from an object, whether in the radio or optical range, it could be shining a laser, for example. That too would be a hint, or perhaps even solid evidence, that it is an artificial object. All these 5 signs I mentioned should raise our suspicions and lead us to certain conclusions. And one last thing I want to say. From time to time, we make mistakes. On several occasions, astronomers have announced the discovery of a new asteroid, only to later find out it was an artificial object. However, it has always turned out to be human-made. On multiple occasions, we have spotted an unexpected object in the sky that had never been seen before in the solar system. We calculated its trajectory based on its apparent motion, and were surprised. Oh, it seems it was launched from Earth a few years ago. And each time, that's exactly what it was. Recently, one of our early Soviet probes sent to Venus was rediscovered. The one that never made it to Venus, but instead entered orbit around the Sun, and we had forgotten about it. The final stage of the launch vehicle used in the Apollo program to send astronauts to the Moon was discovered. Afterward, this final stage itself flew past the Moon and drifted off into the solar system. It circled and circled out there and eventually returned to Earth, even nearly striking our planet. Imagine that. It turned out to be our own creation. Thus, artificial objects have been discovered on multiple occasions, but they were always of human origin. What we are waiting for is for such an artificial object to be created by an extraterrestrial civilization. This is truly fascinating.